Okay, guys, so we're going to pick up where we left off. You don't need to write this. You don't need to write this, guys, but just as a quick review, we talked yesterday, or not yesterday, but Friday, about how this is this. What letter goes here? And then T goes out here, right? So that's what we talked about on Friday. So basically, an exponent that is a fraction is basically a root expression. We also talked about how to break down roots whenever it's not just a square root, but other kinds of roots like fourth roots or third roots, etc. We talked about how when you take the cube root of a negative number, what do you take out? A negative. But if you take the square root of a negative number, what do you take out? 9. So those are different concepts because this is a real number. Negative 8 does have a real cube root, but negative 8 does not have a square root. So that's an imaginary answer, and the other one is a real answer. So those are some of the things that we talked about. And we're just going to build on that today a little bit. I think yesterday, or not yesterday, but Friday, we kind of left the day off with me giving you something like this and asking you to rewrite it like this. And that's all we did. But today we're going to go a little bit further. We're going to rewrite it like that, and then we're going to actually simplify it. So that's the goal. The vocab for today is rational exponents. That's an exponent, right? And fractions are called rational numbers, so it's a rational exponent. All right, so that being said, we'll go ahead and begin the torture. All right, this is example 1. Example 1. I'm not going to put any directions. They're all just going to be basically to simplify. All right. Now, before I begin this problem, you guys, I want to remind you of a basic exponent rule. Okay. We're actually, I'm going to remind you of 2 exponent rules. Here's the first one. When you have x to the a raised to the b power, that's going to be x to the a times b. So when you have something with a power and you're raising that to a power, you multiply the powers, okay? And that's what I'm going to do here. So if I have x to the 9 raised to the 5/3 power, that's going to be x to the 9 times 5 over 3. Now think of that as 9 over 1. 45 over 3. You could do that and just get 15. So there's 2 ways you could do it, and I'll let you guys pick which one you prefer. Okay, here's method 1. Method 1 is, it's like less thinking, but then you have bigger numbers to deal with. So method 1 is just multiply straight across and then reduce. Method 2 is if you don't like big numbers, then you can cross reduce before you multiply, like 3 goes into 9 3 times, and you get 15. So yet that way you don't have to get that giant 45 and wonder what it divides into and all that. But either way, there's that. So that's the point there, is that when you have that, you're just going to multiply those powers together, okay? So write down whichever one you want, either this method or this method. You pick it and stick with it. Cross reduce.
So you're pretty much multiplying the exponent by a unit.
Yeah. All right, let's write down number 2. Ejemplo 2.
But I almost died in the classroom.
There is no good reason for that. I was talking to Ron. Okay, Here's another exponent rule. If you have two things that are being multiplied together and you raise them to a power, then basically you can put that power on each one separately. So if you have x times y being raised to the b power, then that's the same thing as x to the b times y to the b. Okay? And I'm going to use that rule for the next one here. So let us begin. So the first thing I'm going to do is I'm going to write it like this. 81 to the 1/4 times m8 to the 1/4. All right, so let's do this. This is pretty chill. What's that going to come out to be? M squared, because 8 times 1/4 is going to be 8/4, which is 2, right? But what about this? Now, this is where we get to think back to what we learned last class, okay? We're going to actually turn this into a root now. So for the numbers, we're going to go into the root world. So what number goes here? 4. And what number is going to go out here?
1.
Okay. So let's work that out really quick. What times what makes 81? Yep. And then 9 is 3 and 3, right? So the 4th root of 81 is the 4th root of 3 times 3 times 3 times 3. And I'm looking for groups of how many? 4, which I have. They have a baby 3, and then what do?
They leave.
They leave. So what am I left with as an answer there? 3. So I've got 3 to what power? That little 1's still out there, right? So what's my final answer then? 3m squared. So I did two properties there. I split it, right? I simplified the variable part just by multiplying and reducing, but the number one you actually have to do your root stuff with, okay? Sure. A guided practice is necessary. So let's say I had 27 x. I'm going to put a 2/3 out here. And then I'm going to put a 6 right here. All right. So why don't you guys do the first step? Look at the last example we just did. It's like a guided practice. I want you guys to do the work. I want to see how well you're getting it. I'm going to call this guided practice 1. Oh, poop. All right. So I'm going to ask LaFondine, what did you write for your first step? Yeah, I don't think that's correct. You didn't do it, huh? All right. How's about Nelson? What did you put for your first step? Uh-huh. And? So the first thing you want to do is apply that exponent rule where you distribute it to both. All right. Now I want you guys to simplify this piece for me. So go ahead and do that.
A quick question.
Yeah.
Simplifying the other one is.
What did you get for this piece?
I'm still not doing it. I'm still
Okay.
The answer?
No, I wanna get a feel here. John Chavez, what did you get for that box part? What's that? X what? X4. Yeah, you're right. Okay, so how does he get 4? Because you do 6 over 1 times 2 over 3 would be 12 over 3, which is 4. Okay, now I want you guys to do this part. 27 to the 2/3. Let me give you a chance to figure that one out. So the first thing I want you guys to do is rewrite as a radical. So I want to see how you guys did there.
Wouldn't that be 27 squared?
Maybe. We're going to see what Adrian Canizales has to say. Adrian, what do I put here? Good. And out here is 2. Okay. So now you guys are going to do this first. So do your cube root of 27. Shoot. Here. Did you get that yet, Chris? Yeah. What'd you get? Oh, the final answer is 9. You're right. First of all, so if I break down my 27, what does that break down into, you guys?
3 times 3 times 3.
And I'm taking out groups of how many things? So they have a baby 3, and they leave. So I'm left with 3. But there's still that little 2 out there, right? So what's the final answer?
9.
There you go. Okay. Okay, so you guys to try a couple of these bad boys. Yeah, would you guys do, no, would you guys do numbers 3 and 4 here? Now number 4 is easier, so if you want to start with something a little more chill, you can start with 4, but then there's number 3. So see how you guys deal with it. Did you get one of these there? No? Alright, let's see, how about Alexis? Did you get one of these, 3 or 4? Okay. Kenny Shaw? No?
Can I answer?
No. Joanne, did you get one of these? Okay. Which one do you want to do, 3 or 4? 3. Okay. So what did you get for your answer there? Is that it?
And then I got 6.
What?
Oh.
Oh, I see. I see what you're saying. But just your final answer. You didn't divide it? So you got 96 or 95 over 6? Okay. Which it should have come out to be 15 is our final answer.
Yes.
Okay. So let's see why. So the first thing you'd want to do is you'd want to apply the 5/6 to each one of these. For this one, this is why I like cross reducing better, because I really don't want to do 18 times 5. So I would just reduce the 6 into the 18 to make 3, and 3 times 5 is 15. As for the 32, that comes from here. So your 6 goes here, your 5 goes out here, and then you break down your 64, and it just so happens to be 6 2s when you break down 64. And we're looking for groups of 6 identical numbers, which we just so happen to have. They have a baby 2, and then they leave. And then we're left with the 5 there, so you have 2 to the 5th, which is 32.
Wait, all of those have 1, 2.
Yeah. That was part of Friday's lesson. All right, as for number 4. Kendall, what'd you get for number 4? N to the 12th is right. For this one, 9 times 4 is 36, divided by 3 is 12, so n to the 12th. All right. So that's simplifying expressions with rational exponents.
Are we done?
No.
Alright, I'm about to
Let's see. What else did I want to talk about today?
214. We have approximately 36 difference. Give us some time off.
26. You know it's supposed to rain on Wednesday, Mr. Bailey?
I think we'll skip those. Okay.
Already gave them. We should just watch them.
Would you guys please write down number 7? We'll call this example 3.
I mean, I love raising
So what do you guys notice is different this time?
Negative.
Talked about that last time, right? So first of all, we're going to have x to the 2 times a negative 1/2, which is going to be x to the negative 2 over 2, which is x to the negative 1.
Multiply the exponent by the top, right?
Okay.
I get it.
Oh, okay.
We good?
Wait.
All you do is multiply the exponent by the top. And then
So
divide it.
you don't have to
Just like we did last time.
change the negative or anything?
I haven't done that yet. I'm just waiting for people to overcome this
Okay.
the shock of the exponents here. Are we good? Because now we're going to get to the new part. We talked about this last time. Negative exponents do not make your answer negative. What do they do to them? They make it a reciprocal. So you put it under 1. That's what we talked about last time. Okay? All right, write down number 8, please.
Is there going to be bad?
No, this is another example. Okay.
I tried killing you. I blame it on high.
Okay, guys, let's kill the side conversations here. All right, so a lot of this is going to be exactly the same as the last problem. It's just that we have a negative exponent. So the first thing that we would do is we would take this power and we would apply it to both of the terms, the letter and the number, right? So we would have 81 to the negative 3/4 power, and we would have b to the 4th to the negative 3/4 power. Okay?
Mr. Bailey, there's one reason I never leave the classroom during the lesson. That's the reason I come back, I don't know the reason.
Thank you. All right. Now, what would this simplify into? I'll give you a second.
Is it b negative 3?
No. Oh, wait. Yeah. Yeah, it is. Okay. So I'll work it out on the side here.
Yeah.
So as we multiply these, right?
Wouldn't it be 1 over b?
And then you could cross reduce to save yourself some time. That's going to be negative 3. And so you're just left with negative 3 there. But now we're kind of stuck with this guy over here now. Now we got to work on this. Now we talked about this too.
Wait, hold on.
It will. I just haven't done that yet. I'm doing one thing at a time here. So now let's work on this guy a little bit. Well, that's a good question. Let's can I guess I'll come over here. So here's what we do. We're going to turn that 81 into a root, right? What's going to go out here? The 4 goes there. What goes out here? Negative 3, right?
Also, the whole thing can become negative.
Mm-hmm. So we've already done the 4th root of 81 today. What number multiplied by itself 4 times made 81? It was 3.
Oh, so it's negative 9b.
No, you did the exponent wrong. All right, so here we go. What do negative exponents do again?
Oh, it makes it positive because it's 3 times.
They make a what?
Oh my god, I'm so stupid.
A reciprocal.
A reciprocal.
I should get extra credit.
And then it becomes positive after that.
Why is it?
Exactly, it flips.
Where the heck?
I was right. Pretty much. I broke the B.
All right. Now what's 3 to the 3rd power, you guys?
9?
No.
What?
3 times 3 times 3.
Yes. Not all.
27. And then we can go ahead and put these together to get 1 over 27b cubed.
Oh my god, dude. Wait, so every time it's negative, it has to be like that 1 over this.
It's the way of it.
Is this the last one we're going to do?
Maybe.
I just don't want to miss it.
All right. I'd like you guys to try this one really quick, just number 9 for now.
Is that already? Oh yeah, I already did that.
Try number 9. Didn't do it? Okay. David Sanchez, what did you do first on this one, Dave? Like, what did you do first? Like, what was the first step? Oh, like this? Okay, I'll take that. Gabby, what would you have us do next? Good. So if you multiply these, regardless of which way you choose to do it, 6 times 1 is 6. 1 times 2 is 2. It's negative. You reduce it. You get this. So we're at x equals -3. Kayla, what would you have us do next? What would that give us? 1 over x cubed. There you go. Okay. So that's the basic idea there. Now let's apply the same thinking to one with a number and an exponent. Okay? So go ahead and write down number 10. So, step 1. Here's what I want you guys to do first. You're going to have 2 separate things. See if you can fill in those blanks for me. Any thoughts? No? What do you think, Bennett or Rowan? True. Very true. Try one more. How about Danielle?
Put the radical right in the 8.
Okay.
And then do the 3 and the -1.
Okay.
Times.
So you're doing a lot there, and the class is kind of not grabbing this. So I'm going to write, but you're doing good. Everything you just said is good. Here's what I've been having you guys do first, is this.
Oh yeah, that's good. That's that.
That's fine. Okay, so now I would like you guys to simplify this. So go ahead and try to simplify that really quick. -1? Very good, yeah. So basically these cancel, and you're just left with x to the -1. I'm going to stop there with that one. And now I'm going to move on to this. We're going to rewrite it as what we're going to do there. So let's see. Nathaniel, tell me what you write in this little root thingy.
3.
What?
-1, or no, 1.
No, you're right. -1. Okay. Now we're going to break this down. What's the third root of 8? What number times itself 3 times would give you 8? 2. We've done it a lot, so I don't think we really need to be breaking it down too much. All right. Jonathan, what's 2 to the -1 power?
I'm going to confuse you, but I'm going to go with -2.
No. No. Leslie, what's 2 to the -1 power? Sure. Okay, Mike, what do you think?
Oh, wait, I know
the negative
with the 1, the division of 1 and then 2 -1, something like
Close. You're close.
Ooh, it's the fraction. It's 1 and 2, 1.
There you go. So you're right. You do make it a reciprocal, right? But when you do that, that power becomes positive. So it's 1 over 2. So basically, 2 to the negative 1 power is a half. Okay? So now I'm going to come back to y'all, and let's try Paris. What would this be? X to the negative 1. You sure?
Why did you say equal? Is that the same thing?
Yeah. Did I put equals? I don't see
Number
equals.
11.
Oh no, that's a different problem. Michael, how about you? What would x to the negative 1 become here? Very good. Okay, we're getting there. And Kiara, what's 1 over 2 times 1 over x? Alicia, what's 1 over 2 times 1 over x? No? You guys don't know how to multiply fractions? Yeah. Hello. Yeah. So we did it earlier. Remember when we did these earlier? We said top times top, bottom times bottom. Same thing. So we're still multiplying fractions here. So top times top, bottom times bottom is 1 over 2x. That's all. That's all. There's a lot. I think there's a lot of little details you guys are kind of weak in the knees on. So there's a lot of places to trip up along the way here. What are some of the weaknesses I saw as we went through that? Let me see. What did I see? That very, yeah? Oh, because, so that, I think that's a big one for people, is they're having trouble understanding what negative exponents do. They always just, I don't know if this will help. I used to teach my Algebra 1 class like this. You guys ever remember the story of the goats where like they looked over and they saw the grass was green on the other side of the bridge, so they all want to go over there? Okay, so this is like this is a goat,
Did it end up bad?
and he's unhappy because he's negative, right? So what he's going to do is he's going to jump the fence to the other side, and when he's over there, he's happy. Okay? So it's the negative exponent rule. So that's kind of how that works. I mean, if I were to have you guys practice something, like if I said, what's 5 to the negative 1, what's it going to be? 1/5. What's x to the negative 2? Because if you think of this as an unhappy goat, right? He's going to jump the fence, and when he's down there, he's happy now. Does that make sense? So that's the idea. So if the negative exponent rule is a really weird thing, we all really are dying to say the answer is negative. It's not. It actually just makes it reciprocal, and you got to be careful of that one. Yeah.
So you're saying like if there's 2 is like
2. Tell me what you mean. One last chance to grab that before we call it a day. So how about 4x to the 4th power times, or raised to the power of negative 3/2. I want to change that bottom number to a 2. All right, see if you guys can get that. John thinks the answer is 8.
8x to the power 6.
X to the power 6. You're very, very close, but you're not quite there. You know why? It's because it's 1 over 8x.
Yeah, that's what I said.
Hey,
Okay.
can we do that on a test? Like, put it all over 1?
Yeah, so you could. So here's what you could do. That's what Joanna was asking about earlier. You could just kind of ignore this if you want. Solve it like we did in the first few today, and at the end, just put your answer underneath a 1. It'll work. So it's the same thing. But the problem is that you'll probably forget to do it. You know what I mean? So you gotta be careful. I'll show the work in case you're wondering.
Yes.
Bro, that's how I felt when I made TC. From Texas. I was so sad. I was like, I'm gonna make it.
Oh, I'm not sad. I want to do it.
But like, I mean, I was still not here. Like, nobody in my neighborhood. We're not really friends.
Well, that's different. I had
You actually.
and I moved a whole other state. That's and then I got comfortable for 3 months, and then I moved again. And then I got comfortable for 2 months.
Why are you